finally got around to doing this video, and what we're going to look at today is, first of all, getting the OS onto our 4 NVMe drive, Raspberry Pi 5. Then we're going to upgrade our networking to 2.5 gigabit. I've got two different varieties of adapters here. And then we've got this one from Ugreen. Now, I could have gone and bought a ASUS at $60 US for a device, or $30 US for one of these. So we're gonna have to just see how Ugreen does, because I could get two for every device I bought. So I did buy a bunch because I want to upgrade a whole bunch of other stuff. So I bought another three. So the device looks okay, and it's got a Realtek chip inside of it. So we're going to see which one behaves well. This is approximately the same price on both of these. This one is just slightly smaller. The Ugreen one, I don't think that's metal. I think that is just plastic. That's got a metal finish or metal coloring paint. All right, so let me hook up the Pi KVM and let's get cracking. All right, I've powered both the devices up. Pi KVM is booting up. We can see that from the little hello sign. We need some network cables. Here we've got Ethernet cable number 1. We'll just for now use the 1 gigabit. Come on. And where is number 2? And we've got number 2 going into the Pi KVM. I also got a second one of these. It's not showing up very well because it just to zoom out quite far, but it's a TP-Link 2.5 gigabit 8-port switch, not managed, so it's cheaper. I've already got one of these. I just needed more ports, so we can test on a dedicated network device with no other congestion. It running off the SD card, Raspberry Pi OS. And if we look at gparted, I've installed that so that I can fiddle with the partitions. And if we look at our NVMe drives, they are all empty. Okay, so step 1 is let's get an OS onto the first NVMe drive, and then we'll start fiddling around. So the way we do that is we're going to use the imager. Looks like I have to double click. We're going to choose the Raspberry Pi 5. We're going to choose the OS. And I'm going to be, whoops, a daisy, don't scroll so crazy. Raspberry Pi Lite 64. Full OS. Now we want the Lite OS. We're going to write it to the first NVMe drive. And do we want to edit some settings? Yes, let's do that. Just going to call it NFS1. I've got my default username and password in there. I'm not going to set up Wi-Fi. We're going to use password authentication until I can get everything else on there. All right, so NFS1, here we go with the US keyboard. Save. Oh my. All right, I'm just going to drag this off screen and quickly type in a password. Right, password has been typed. Say yes, and yes, continue. I will fast forward through this because this is going to take a little time. So there we go. We've got an OS onto the first NVMe. Now, if all goes well, if we power this off, log out, shut down, I'm going to just stretch over to the workbench once it's shut down and pull out the SD card. Right, the SD card is out and I've powered it back up again. There's two reasons for this. I want it to run through its initial boot up process of generating the SSH keys. It will reboot again. It will grow the root partition to the full size of the disk, which is obviously not what we want. Interesting, those commas for the colors on the screen. Don't think that's a PyKVM thing. I think that's just probably terminal issues. Right, so now let's see if it powers up properly. Yep, this is the normal boot process. Okay. We're shutting it down again because we've done as much as we needed to do there. Now I'm putting the SD card back in the device and booting it again. Right, SD card has been placed back in again. Power button has been hit. Now we're going to start customizing the OS to do what we want to do. First things first, we're going to go to gparted. And we're going to move some partitions around. So there's where it wrote our OS. And interestingly enough, it's got a little exclamation mark. I'm not sure exactly what that is about. But I'm going to squeeze the OS down to 10 gigabyte. And then I'm going to take 10 gigabyte on this drive. So let's create two partitions in here. New, and we'll make the partition about, and I'm just going to eyeball it. I'm just going to go 10 gigabyte. And that partition is going to be, actually, let's make this bit at the end a nice round number. There we go. Ooh, that's a little bit too round. So let's go 36. And we'll just, oh, really? That's not a nice number. Yeah, it feels a little bit not so well rounded. Right, let's do that. I'll copy that and keep it somewhere. 234200. I don't think it really matters, but it says align to, I think that's probably what we want, is align to cylinder. But anyway, they want to align to megabyte. And this partition is going to be an ext4, and what we're going to do is name this partition so we can find them again. So this one is going to be the home partition. So I'm going to move home to there. And then I'll create another partition over here. And this one is going to be interesting. We're not going to put an OS on it. We're going to put interesting. So it doesn't, we can leave it as unformatted. I was hoping that they had a way to mark it as a ZFS partition, but that's fine. Unformatted is fine. So I'll go to the next one. We'll create a new partition again. And then here we've got that same problem. We want to, did I copy it correctly? Yes, I did. All right, excellent. And this partition is going to be ext3, and this is going to be our var partition. So all our logs and stuff will go over there. And 10 gigs of log is quite a bit. The nice thing is I can load like an OS, a MySQL instance on there or something like that, or Docker. If I have a couple of Docker instances on there, they will run in var. So I'm just giving myself a little bit of future expansion there. And then we'll create another one over here, and we'll call it, oops, not prime, I'll call it unformatted. Okay, then we'll go to the next drive, create another new one, paste that, no, other way around, my bad, like that. And this is going to be interesting. We're going to leave this as a primary, but we're going to do this as swap. So 10 gig swap. Because it's an NVMe drive, I can actually swap to it. So we'll just leave it like that. And I forgot to name the other partition, so I'll just do that as well. So this is going to be our unformatted. Just go over here. This one wasn't named, so... Oh, it is named. Sorry, my bad. It's got var. And this one's got home. Yep, it did have a label. All right, so now we go back to the first partition, first drive. So the first drive we've got to shrink, right? So we're going to go and say resize. And we're going to say we want that much free space at the end. So now the free space is exactly the same size, also aligned to the megabyte. Now it will be sensitive about this, but you know, we're going to just bulldoze straight ahead. There's no configuration on there, so if we lose that drive because of our resizing, you know, it's not the end of the world. Okay, unformatted. And there we go. So we apply all of these changes. It says, yep, apply. And there it goes. Okay. Interesting. I still got a little exclamation over here. I wonder what it's... Doesn't say why it's unhappy with this little exclamation. Hovering over it does not result in anything either. Information. Unable to detect the file system. Well, that is perfectly correct because we haven't got a file system on there. And then this one, what is the reason for this guy? Oh, so it looks like this particular OS that I'm on doesn't have FAT32 support, which is remarkably odd, but hey, to each his own. Maybe it is because I did reboot, so it's not like it's got a partition table issue. Anyway, so now we've got our drive partitioned. Now we need to fix it up. Now the trick is we'll have to do that in a terminal. It's going to be nasty to do it like this in a KVM, so let's just switch over here. Let's get to the Raspberry Pi. I hope this is not too small. I'll go one size bigger. Now what we want to do is we'll go to Media, and we'll mount /dev NVMe 0 N1 partition 2, which is our root partition now. And we'll mount that on OS. So if we go into OS, there is our root OS partition. Okay. Then we're going to go we're going to mount the other two drives. Okay, let's start again. So let's just go, just to remind ourselves. So that's what we did to mount the OS. We're going to mount two P2, NVMe 1 N1 P1. So that's the second drive. So let's just remind ourselves in the UI. So we did the first drive and we mounted that partition as our OS. And then we went and mounted the next one down, which is going to be home. We mount that on home. Now it's just in, I already created these folders. So these folders just exist inside of the media partition, right? Then we're going to mount N2 P1, okay, on var. So if we go do that, N2 N1 P1, which is var. So we mount that on var. And that's pretty much all we need. Now we go into the OS partition and we want to put the contents of var onto the var partition, and we want to put the contents of home onto the home partition. So we'll go to the destination. So we're in media, go back one, add into media, we go to var, then we go rsync, and we do an rsync -a -- devices -- special -- hard links, and we go media os / var to /. Right. So now if we do a listing over here, this is how var will look at it. It should be a perfect copy of what was on var. And you see there is a swap file. I'm just going to remove the swap file because we're going to switch to swap partition. There's a way to do that correctly, but we'll get there. Then home, we're going to do the same thing. We're going to go back to our rsync, and we're going to rsync os home to here. So there's the Charles folder now with all my files. There's not real any files in there, but just the structure and permissions is there. All right, so now if we're going to mount these two partitions back onto our OS drive, there is already content over there. So in var, there's already a bunch of contents. So what we do is we're just going to rm-rf var and rm-rf home. Then we just make the folders var and home. Now var may have had some special permissions. Let me just double check. So var was just 755. Okay, ch own. And I think that's already the case. Yep, var is 755 and home was 755 as well. Okay. When I say 755, I'm referring to these permissions. So directory and then rxw, that's 7, r-x is 5, r-x is 5. Okay, so that's good enough. Now we just need to tell this OS in the etc partition that it needs to mount these things correctly in its FS tab. So currently our only entries in the FS tab is going to be our proc file system, our firmware, which is the vfat partition, and our root partition. But we're going to need a couple more. We're going to need one for home. Maybe not that many, couple or more, but we are going to need that last one as well. Sorry, my bad. So we're going to need var, and we're going to need undo, insert home. And this one is just going to be none. And then this is going to be swap. I can't remember what swap is going to be on this side. So we'll see. I think that's 0, 0. Those ones would be fine as 0, 2. And I think this just gets defaults. But we're going to discover it together. Now we just need the IDs of these other partitions, right? So what I'm going to do is I'm going to open up a new terminal. Make it a little bit bigger. SSH. Oh, come on. SSH to Raspberry Pi. And then what I'm going to do is I'm just going to do an ls blk. So we can figure out what we want to do where. So what they do is they're using the part UUID. So if I go lsbl, no, not lsblk, what is that thing? BLK ID. There we go. So if I go BLK ID, it will give me all the identifiers for a particular device. You may remember in the build video, I said that Linux likes to swap these devices around, but it's still got a unique identifier. So we're going to use the part UID, which is this one at the end here. So we're going to look first of all for home. There's home. I'm going to copy that. We're going to go over here and we're going to go to home. Insert, and we're going to paste that there. Now, very important, take away the quotation marks, otherwise you'll end up with a whole bunch of tiers. And I think we could probably just get away with just doing the ID. So now we want var. Var is this guy, so we just want this number. And we'll pop that into there. And then the last but not the least is our partition for the swap. So let's go back here again, and there's our swap. All right, so we've got, let's just match these others to see if they're the same. See that 313 ending in C2 and then 1 and 2, 1 and 2, that will be the vfat partition and our root FS. Interesting, this boot FS over here, I'm not sure what that is Oh, of course, those are the those are the SD cards. So that's why it's duplicated. That's the SD card. All right, so it looks like we've got all of that working. Now, it says here, a swap file is not a partition. So if you want to do this, do this thing to turn that off. Now, if this tab set up correctly and I've saved it, now we're going to see if our device boots okay. So we're going to get out of there and we're going to type reboot over here. All right. The streets aren't running with blood just yet. So I think it took what we told it to do. We've presented with a console. Visible to us, but anyway, let's just do that again. So let's just go through. These are virtual ones. There we go. There's our first one. That's our front / partition. That's our root partition. Then we go, keep going down. Here we go. Our var partition, our home partition, and our boot partition. So it did actually do what we asked it to do. Let's see if journal control -xe works. Yep, that's definitely reading from the right place, I think. So let's see in log. Cat. Okay, so most logs are empty. I'm just trying to see if there's anything. Well, if we do an apt update, whoops, then that's definitely writing to the temp folder. To the var partition, sorry, that's where the caches are written. So, excellent. Right, so let's go etc, and then we go apt, then go sources.list.d, then go raspi, archive.raspberrypi.com. So we're going to go deb, paste that, and then we're going to go Debian, then we're going to go bookworm, and then we're going to go main, and we're going to comment, oops, a daisy. Comment out that, and we don't have to worry about it. So let's see what will happen. Apt update. Oh, because I can't spell. All right. Australia. Okay, so we just need to add an AU in front of Debian. Okay, so close that. Let's grep -r deb.debian star. So it's in sources. So you have to use deb on that one. Yeah, that looks a lot better. What a couple of mirrors can do. Apt -yes full -upgrade. Right, so that's built the init RD. Before we do anything further, let's just do a reboot. SSH to NFS1. Become root. Now, First thing we want to do is we want to do apt install Raspberry Pi dash kernel dash headers, and then ZF. Let's install that one first by itself. Right. So that's going to make it possible so that we can compile the ZFS module. The ZFS module uses a different license than the Linux kernel. And that causes a couple of hiccups. So we'll do that one first. So you have to build the module. It cannot be distributed in binary form. All right, let's get those two puppies installed. Now this is going to take a good while. This is going to be building it on a Raspberry Pi 5. So this is going to be sorry, swap on. There we go. So it's saying I'm using the partition that we gave it, but it's also using the swap file, which is not what we want. Off. Var swap. Oh, you just have to do swap off. Could it be as simple as that? Oh, that's setting it, existing, keeping it. Swap off. Oh, uninstall. All right. So there we are. Now I'm going to plug in the 2.5 gigabit Ethernet adapter. All right, so that said, reset super speed USB number 2, RAM code speed up mode fail. That does not bode well. Right, we're back in, become root, swap on. Yes, finally the swap is sorted. All right, now we need to create our Z pool. So if we go Z pool list, no pools available. So we go Z pool create my pool. You can call it anything you want. And the devices, okay, well, before I do that, let's just do an LSBLK so we can see the devices that we're going to use. So it's all of these 228, 228, 228, and 228. 228, yeah. So let's do that. So we go zpool create, let's paste that bit. That's going to be dev nvme 0 n1p3, which is that one. That's going to be dev nvme 1 n1p2, nvme 1 np, nvme 1 n1p. Wondered why I didn't complete that, because I can't type again. NVMe 2 n1p2 as well, and then dev NVMe 3 n1p2. All right, now this is going to create a striped pool, which means no redundancy. It means if one of the drives fail, all the data is gone. I don't particularly care about the data. All I want to do is have the fastest, lightest CPU usage writing to a disk, and I'd like to scatter it across all 4 of them so that they all take the same type of wear and tear. I'm going to basically use NFS for this, so it's just going to be for temporary data, and it will live for a couple of days. I'll destroy it, and if the drive dies, I've got a couple of these as backup, and I'll just put them back. So let's create the pool. Now if we go Z pool status, we'll see that it's my pool, it's online, and it's made up of these 4 devices. No known errors. All right. Now we can create our ZFS. So we can create, and we can actually specify a size, or we can just let it grow to the full size of the thing. I'm just going to give 1 partition. So I'm going to create my pool K8S, which I'm going to share across the network. Okay. And then I can do snapshots, all kinds of cool stuff with that. and then we need to make sure that we export it. Now what I need to do is, I've already done this, but I'll just show you the command. So I need to do apt install nfs-kernel-server. That will install the NFS server. It says it's already at the latest version, but if I go show mount -e, nothing is exported from NFS1. ZFS, and then we want to set share fs equals, and then we go read write at 192.168.0.0/20, oops, 0/24 of my pool slash K8S. All right, so that will say we want to share it. Is it share NFS? It could be share NFS. I think that might be the actual flag I need to type in there. Yep, share NFS. Share it via NFS. Make it read write to anybody on this subnet over here, on this class C. Now if we go show mount -e, boom, there's our mount. Let's see if our mount is available over here. I tried it a little bit earlier and it was very unhappy. So what we do is we do mount -t NFS, and I can actually do NFS4 N1 my pool K8 on it. There we go. Ooh, let's just clear the screen a bit. Okay, there we go. My pool, type NFS version 4.2, and it's got a couple of things. It's actually, it said its read and write buffer sizes nice and big. So we should be able to do some speed tests and see where we end up. Let's take a look-see at iPerf, which is going to give us a bit more accurate of a result. I'm on Brock, that's my workstation. I start the iPerf server. I go back to NFS1 and I run iPerf on here. And iPerf will now send a whole bunch of traffic between NFS1 and my workstation. Both of them connected to the same 2.5 gigabit switch. I have also copied all of the video files for this project onto the same NFS share, and I can prove it to you here. So there is the NFS share. It's actually my NFS share, and I've copied all the files on there. I've got a Kden Live project open at the moment on here, and I'm scrubbing through the video files across the network, and you can see this is this very video that you're watching right now being edited while we're running an iPerf 3 performance test at the same time. There was a little hiccup there when I was scrubbing, but other than that, it's just been cruising through. So I am remarkably impressed by this device, and I would really recommend it to anybody that wants to do video editing, for instance, that needs a lot of storage, and you've got money for large NVMe drives and you want to get full speed. We will take a look in another project at a SSD based version which uses it can plug 5 SATA SSDs into a Raspberry Pi 5, and we'll see how that goes. Well, thank you for watching the video, and I hope you enjoyed.